lot of time and patience on on behalf of the organizers and members of the scientific committee. I'm sure they have devoted a great deal of time. It is not possible to achieve such a thing in such a short time. The mathematics and mathematical discussions, these are the focal points of this conference. This is unlike a physical conference where there are many social events where people can meet and greet each other. We do have social programs or panel discussions here. If there was a physical conference, we could have met many friends and discussed mathematics during the lectures or a cup of tea and while taking morning and evening walks. These attractions are not there in this conference, but there are survey lectures and very interesting topics that you have just heard by some of the best researchers in India. There are short presentations by large number of young researchers. So it seems to me that this is an event by young people, for young people, and I'm very happy to see that people with such short experience can come out with a conference of this kind. It's really heartening to see this. It is our fond hope that the young researchers will get some valuable lessons when they listen to the survey talks. That is the main aim of this conference, to promote mathematics. It is my belief that these plenary talks in the mornings and evenings will inspire all of us to take up challenging problems for research. A conference, after all, is a congregation of people who want to listen to seminars. And the Webster's dictionary meaning of seminar is that a seminar is a discussion with an expert, or people who want to learn the subject which is being exposed by the expert. So during the seminar, I request all of you to actively participate so that the lectures are as lively as they could have been if there was a physical meeting. We have to really make special efforts to make this conference useful, interesting, and a memorable experience. Speakers have put a lot of effort to plan their presentations, and I request the participants to ask good questions and have a lively discussion. Especially request the speakers to state some open problems, because this is really the test that if this conference can inspire many young people to take challenging problems, which will make us all proud if they solve them. So the conferences of this kind should aim towards informing young people about the current problems which people are trying to solve around the world. So long ago, I read a classic book by Halmos. I'm pretty sure many of you know this book. The title of the book is I Want to Be a Mathematician. And this is the title of the last section of the book. It's a fat book, but once I started reading this, I finished it in a day. You cannot just put down this book. It's a funny book, and at the same time, it is extremely useful. So Halmos has advice about almost all professional aspects of a mathematician. He tells us how to study, how to learn, how to do research, how to teach, and how to write a paper, how to deal with the rejection of a paper, how to write a book, or how to be head of a department, and how not to be a head of department. So he has very interesting discussions about these things that we come across in our everyday life, at least in the life of a mathematician. And as I said, the last section from which the title of the book is derived is entitled as How to Be a Mathematician. And he says that the first condition to be a mathematician is to love mathematics. And then he says, Halmos has been an outspoken mathematician all his life. And he says that you will love mathematics more than your religion or your family or your friends. This may not be possible for all of us, but we understand the spirit of his advice that you have to be really passionate about mathematics to be in mathematics profession. Now, there are many kinds of advice that he has in this book, as I said, but he tells us how to give a lecture of 10 minutes or 20 minutes or half an hour, or how to give a colloquium talk, how to give a series of lectures. And these advices are, from his personal experience, and I have found these extremely useful while preparing my talks. So about a 50-minute talk, he says, an hour-long lecture by its most common definition is a 50-minute performance. So he thinks, and we all see, that presenting mathematics is no less than a musical performance. So he says, plan your talk for 50 minutes, and it should not be a chapter from a book. It should not be a complete exposition of your recent work on harmonic analysis. His area was analysis. And then he says how much effort many successful speakers put in their talk. So he gives example of famous mathematician Carmichael. And he says that Carmichael put 50 hours for a 50-minute talk. So it's like 1 hour for every minute. So when we listen to talks in ICM and some other very good conferences, we come out by praising the speaker. But behind a beautiful talk, there is a lot of hard work. And Almos himself was a very demanding mathematician. He says he used to write his lecture whenever he got a invitation to give a colloquium. He would write his lecture, and then he will dictate it in a dictaphone and then listen to it. And he became his own critic. He will revise the lecture many, many times until he was himself satisfied. Finally, he will prepare the slides and then a final rehearsal. Then he says, however short a lecture is, a mathematics lecture must contain a mathematical proof. It can last for a minute if it is a short talk, but a lecture in mathematics without a proof is not really a lecture in mathematics. So I urge all the young people to read this book. It is extremely useful, especially for participation in conferences and for planning their lectures. I'm hopeful that such conferences will be organized every year. We will see an edition of MathFest 2021 next summer, whether the virus is going to stay here or not. But such types of meetings, which are inexpensive and which can bring a very large number of mathematicians from India and hopefully in future from abroad, will be organized every year. It is really a task of young people who, for whom technology comes by intuition, unlike older people like me who cannot see obvious signs on the screen what to do. So I hope that the young people will continue to organize these meetings. And these days, as one of the organizers said, that we see during the Corona news, we see mathematics in action. People have become used to looking at the graphs and V-shaped graphs and various ratios. And so mathematics seems to, and statistics in particular, seems to have become even more popular among the public. But we all know that mathematics has been at the center of major developments throughout the civilization, and all the modern developments in science and technology, they have come because of mathematics. Whatever experience we are having now, it is possible because video and audio can be compressed using tools of coding theory. They can be transmitted so that the mistakes are very, very few. Without mathematics, I don't think such things are possible. So we should, in our panel discussion, try to impress this point that the mathematics is at the foundations of all science and technology developments. And even the current revolution which is happening, artificial intelligence and machine learning, it is based on basic subjects like linear algebra, convex optimization, probability, and statistics. Without these, such things will not be possible. Self-driven cars will not be there. And now I read that the best advice that a doctor can give is actually derived by machine learning algorithms. We are in for a very exciting time, and this is happening because of mathematics. I invite all of you to attend and enjoy as many talks as possible. The talks start at 10 o'clock and they continue up to 10 o'clock at night. So whenever you are free, you can start and log in and enjoy a talk. And I request young people to participate actively and ask questions so that you take away some interesting research problems which can result in a good paper and keep you engaged until the next year when we have one more conference like this. So thank you very much for giving me this opportunity, and I wish the conference a great success.
Thank you, sir, for such a wonderful and inspiring speech and telling us how to prepare for a mathematics talk. Thanks a lot. Thanks a lot.
Thank you.
So, yeah, so we'll be moving to our next inaugural talk by Professor Ravi Kulkarni. So he is an eminent mathematician known for his work in differential geometry, Riemann surfaces, and group theory. He was a professor emeritus. He is a professor emeritus at City University of New York. After serving 30 years at several universities in the US, he returned to India as the director of the Harishchandra Research Institute in Allahabad. After the directorship, he joined IIT Bombay as a distinguished visiting professor and also became the president of the Ramanujan Mathematical Society. Also, he is a founding member and founding president of the Indian Mathematics Consortium. Currently, he is a distinguished professor of the Vaskaracharya Pratisthana, Pune. Okay. So I welcome Professor Ravi Kulkarni to give an inaugural speech. Sir, can you please unmute and.
Okay, can you hear me?
Yes, we can hear you.
Okay. Well, thank you for this invitation. And I really congratulate the core organizing committee, consisting of 3 people from at wide distance. Dr. Soumya Dey from IMSC, Dr. Saurav Sen from HRI, and Dr. Sayan Chakraborty from Kolkata. And they're organizing this virtual Math Fest. I know that thanks to Corona, some classes at the universities are being organized online. And I attended a workshop which was going on for 1 month at similar but less advanced topics. But this is the first math workshop was going on for 1 month. But this is the first Math Fest online running for a week, which I'm attending. Corona has indeed forced this format, but I think it is a boon in disguise. When I had postdoc positions, I attended a few seminars and even organized some. We used to invite speakers, mainly from nearby universities, and to invite a person from a distance always involve travel and accommodation charges, and besides honoraria, of course. And that was a major expense and major deterrent for inviting people, in famous mathematicians and so on. So the major conferences were always arranged by senior people who applied for grants from major funding agencies. Nowadays, the funding agencies, their funding has decreased. And now person-to-person meetings are surely better, for you can discuss many things over a cup of tea, over lunches and dinners. But online meetings are not much worse. We can still see each other on screen. Hello? Can you hear me?
Yeah, we can hear you. Yeah.
And the online meeting has the advantage that if people want to, they cannot use sticks and fists. Even that used to happen sometimes, I remember in my career. I am happy to note that the organizing committee of this fest is coming from 3 different institutes, as I stated. I know such meetings are becoming common in the United States and Europe. I hope they become common too in India. And all this is due to technological advances which are used in these online meetings. I would address the rest of the talk, especially for postdocs and students in the audience. The 4 plenary speakers you are invited in this fest are well-known experts in their respective fields. Whether you are actively working in this expert area or not, I would very much recommend to you to read the abstracts of these talks very carefully and try to understand the historical context and the current research in these areas. It is very important that you equip yourself with at least 3 or 4 different major areas of mathematics before you start any serious research, which will help you, first of all, writing some papers, get jobs, but more importantly, also a real contribution to our discipline. Among these talks, the talk by Siddhartha Gadgil is of a different nature, as I understand it. It is motivated by development in biology. This is a bit different from interdisciplinary work. The word interdisciplinary refers to a particular problem in a particular area and solving it by combining techniques from 2 or more different disciplines. I do not quite know how the work which will be reported by Siddhartha, but it has resulted from a development in biology. The problem the biology suggested in mathematics. And we certainly know the disciplines like mathematical biology, where mathematics is used for solving biology problems, or mathematical physics is a very old discipline, using mathematics to solve the problems in physics. But Siddhartha's work seems to be in the direction of biological mathematics. That is, different types of questions posed in mathematics because of the motivation coming from biology. Only a part of that will be of immediate relevance in the present day biology. It shows the pervasiveness of mathematics. Many people say that mathematics is not a science. Its data is not material. It's not in a lab, or it's not even an observational science. It does not deal with matter, but the data of mathematics is mental on the abstract level. Pursuing it may solve the specific originally posed problem, plus, or it may show that this problem is not solvable, like the famous Euler's theorem on the 7 bridges of Königsberg. Mathematics is basically a theory builder. All theory building is really mathematical. In this manner, we are now talking about physical mathematics. That word is already used in physics. Mathematics suggested by physical problems. But now you see this biological mathematics in Siddhartha's talk. The other three plenary talks will be by Professor R. Balasubramanian, Gautam Barali, and Eknath Ghate. They are summarizing the substantial developments which have occurred in the last 50, 60 years of their disciplines. Try to grasp how they have developed in their historical context. Because starting working on a problem, and you should not see just the latest developments and where you can put the some eyes, but also to understand how the problem arose in the first place, what historically people actually asked, how the problems were initially posed, and what developments have taken place in that manner. And so are the other talks.
Sir, can you please unmute yourself? Can you please unmute yourself?
Yeah, we can't hear you. Something, some happened.
Yeah.
Somo, you can unmute. You are a host. You can unmute.
No, this is a technical problem in the device.
So again,
we can hear you now.
Yeah, now it's fine. Yeah.
No, I think I cannot hear him.
Sir, could you say something?
Could you please unmute yourself, sir?
Is there a loose connection somewhere?
No. I mean, yeah, now it's okay.
No.
Okay, all right. I would say that mathematics of the first half of the 20th century was, I would say, existential mathematics. People were interested in showing existence of solutions. But now that computers have come around, we can ask many more precise and constructive questions, how to actually construct a solution or enumerate something. I remember some recent work of Gopal Prasad, in which he and his many collaborators constructed over 200 homotopy complex projective planes. A lot of computations were needed. Work was going on for 4 or 5 years or even more, I think. And the team consisted of some theoreticians who know the original problems. The problem is just to classify certain objects. So one knew that a homotopy complex projective plane, that is two-dimensional complex surface, is actually need not be a complex projective space itself. So how many such spaces are there? And I think somebody proved they were finite in number, and that was another type of discussion that went on in our generations. But now the work is more precise. Enumerate them. And I think they enumerated some 240 or some homotopy complex projective spaces. And I guess they know also how to construct them and so on. This was also the question about the homotopy spheres, differentiable spheres. And Milner's well-known work in 1960s. There again, and I think some of those areas have not been completed yet. And so there is a wide scope for any type of research along those lines. You can see that team which solved this Gopal Prasad's problem were some theoreticians who knew the original problems and others who had some, how to put them on computer and how to verify possible conjectures from time to time by using computers. You will know, or you can imagine, and you will soon come to know that 70–80% of the conjectures are false, as they are stated, but need some modifications. it also makes clear some additional hypotheses to prove a theorem that you need. And you can see the necessity of that hypothesis by working on computer. Well, computer can solve only finitely many stages, but there are enormously many which our human brain cannot handle. And so these are these interconnecting developments between mathematics and computer science itself has its own mathematical problems, and so on and so forth. There are many such areas, and I think you should have your eyes open to sense where the problems are, and which your present day advisors who are about 50 or 60 may not be aware of. A sad note of this fest is the passing away of Professor C.S. Seshadri, a great mathematician of my generation, and also a great successful institutional builder. He was senior to me by about 10 years. I knew him well from my student days at Harvard in 1964, when Seshadri was invited for an extended visit. I think Professor Mumford invited him, whom many of you may be knowing. He's also now very old, I think about 80, 84 or something. It was so exhilarating for me to see an Indian face among the illustrious mathematicians. Mathematics is a profound subject, and our culture has known its importance and has contributed to it in the past. But maybe I think it is contributing more now in the second half of the 20th century. And so I invite you all to join this tradition and make your own contributions. And I'm very happy that Balaji is contributing a session on life and works of C.S. Seshadri. So you please attend that and see how his mathematics developed. Okay, that's all I would like to say.
Thank you, sir. Thank you. Thanks a lot for your inspiring talk and speech. Yeah, it's really a sad note that at the very beginning of the conference, we lost such a great figure in mathematics. Yeah. So okay. So let's move on. So I would request the other members of our organizing team, if they want to say something. Maybe Divakaran, are you here?
Let me ask you one question.
Yeah.
Do we need different links on different days?
Yeah, exactly. We will be sending at least 2 links to everyone. So some of the events will be open to all, like this one. So we will be advertising the Zoom links, and anyone can enter in that session by clicking on the Zoom link. The other, symposium talks are more focused. So we have decided to keep few participants inside the Zoom, and most of the people will be watching it on YouTube. And of course, the YouTube participants can ask questions through the live chat, and we will be looking through the questions, and we will be collecting questions. And during the question answer sessions after the talks, we will be addressing those questions. Okay. So this is the plan. So we will be sending different links for different type of sessions. Okay. Yeah. So yeah, if Divakaran, he's here.
Yeah, just to add to what Soumya said,
yeah,
is that we have a limited number of people who can attend the Zoom meeting at a given time. That's the number is 500, and that's a technical limitation, and that's why we have to keep this tradition of keeping symposium talks to certain people and sharing everything else to YouTube channel. It's a limitation of technology, not for the organizers, but the technology.
Yeah, of course, we of course want everyone to come, but it's not possible always. Yeah. So so I guess Divakaran is not here. If
no,
any other
Divakaran is here. I can see him in the list of participants, but
can we unmute him?
Asked to unmute. Yeah, I've asked to unmute him. Yeah.
Yeah, I'm here. I was muted. I couldn't speak. That's the only reason why I was staying silent.
Okay.
Yeah.
In fact,
Okay.
I sent a message saying that I'm here but muted. So yeah, not that I have much to say. Maybe I should start my video. I don't know. Not that I have much to say. In fact, I did very little for the conference. All I did was be a sounding board for some of the discussions. That's about it. But yeah, I'm very happy that everything is going well. We have a lot of participants, and the line of speakers looks like wonderful. So I'm also looking forward for all the sessions, and let's hope things go well. Yeah, so fingers crossed. Let's say that's about it.
Okay. Yeah. Anyone of the other members, maybe Tulsi, Prathamesh, if you're there, you can speak.
Hi.
I am here. Can everyone hear me?
Yes, we can hear you.
Okay. Again, like Divakaran, I don't have too much to say. I think I was only very tangentially involved in the planning, but I do want to thank both the speakers for today for very nice inaugural talks, and also thank the three members of the core organizing committee. I think you put a lot of work into this, and we are all really looking forward to the talks.
Okay. Thank you.
Hi. Can you hear me? Hi.
Yes.
Hello, this is Prathamesh here.
Yes.
Okay, yeah. So can you hear me? Okay, yeah. I'd just like to congratulate the organizers for doing such a fantastic job. I mean, especially at the level of postdoc, I think this was a fantastic endeavor where you're trying to take math to many different corners, and as well as to basically fellow peers as well as PhD students. I think this is a fantastic job that you guys have done, and especially both the list of speakers and the talks are exemplary. And I was also very fortunate to hear great talks today, both by Professor Jugal K. Verma and Professor Ravi Kulkarni. And one of the interesting points that Professor Ravi Kulkarni made is the shift from a more existential theory of math to a more computational theory. And that's something that I think people should try and just have a bit of a eye for, because of the developments in computer science, both in terms of framework of building algorithms as well as logic and verification of proofs. So I think that's something that would be really worth for youngsters to watch.
Yeah, thank you, Prathamesh. Okay, so anyone, so other scientific advice, I guess Jam is not here. Maybe, okay, I guess Professor Amri is also not here. So, okay, so before closing the event, I would like to thank everyone for coming. I would like to thank Professor Jugal K. Verma, Professor Ravi Kulkarni, and Professor Krishnendu Gangopadhyay for coming and joining us and inspiring us with words. Lastly, I would like to add that our event is being supported by the Institute of Mathematical Sciences by giving funding. Okay, so I would request maybe the participants, if they have something to say, something to share, they can also speak for a few minutes. Yeah, if you have some questions for us.
So anyone can unmute themselves and speak, I guess.
Right.
Yeah.
But don't speak over each other, right?
Yes.
Yeah. Be gentle. Be gentle. Yeah.
Yeah. Hello, sir. This is Saurav Roy from TIFR camp. So,
hi.
Yeah. So I am wondering that whenever we will ask professors about the questions about the topic of the talk, so it will be in the end, or as we can interrupt in between the talk.
No, after the talk.
Okay.
So you if you are in the Zoom session,
Yeah.
we will be keeping all the participants muted. Only in the end we will be allowing you to unmute and ask your questions. But if you are watching it on YouTube, you can write your questions on the live chat, okay, anytime. And the moderators will be looking at the live chat and they will convey the questions to the chair of the session. And in the end, during the Q&A session, some of the questions will be answered.
Okay, thank you.
So, Somo?
Yeah.
Yeah, so I think these plenary talks, they will be live on YouTube, right?
Yeah, exactly.
Yeah.
All the talks.
All
the talks will be live on YouTube.
Including the section talks also.
Yes.
Yeah, all of them.
And there is one link, or I think for the YouTube.
Yeah, that's what I told, that so there are two types of talks or events. One is open to all, like this one. So we will allow everyone to join the Zoom. And for the symposium talks, which are more focused, I mean, mathematics talks, for that we'll be not allowing everyone to inside Zoom, and everyone can attend on YouTube.
Okay. So for the YouTube link will be the same, which is given on the website.
Yeah, everything will be updated on the website, on the live page. Okay, everyone should keep looking at the live page and program page, and also the notice board page. So these three are most important pages in the website. Everything will be updated.
Hello. Sir, this is MEGHA Pandey, a research scholar from IIT BSU.
Yeah.
Sir, as you are saying that some talks will be allowed for the like symposium talks are not allowed for everyone. So who are allowed for those talks?
Yeah. So basically, some people we have got registrations, and among the registered participants, we'll be allowing some of them. So if you are interested to know the algorithm of how we are choosing, we can also do that. So can you please send us an email? We can write in the email.
Okay. So I have registered for this. I get an email.
We can't hear you properly.
I should send the email.
Sorry, I can't hear you.
Am I on?
No, you're
not properly audible.
You can write on the chat box whatever your comments is.
You can
write on the chat box.
Okay, just to clarify the point, all the talks will be available on live in YouTube. So you can, in the current time, all the talks, whichever talks are going on in the conference, will be available on YouTube. You can watch it there. You can ask the question in the YouTube chat box, and we organizers will keep an eye on the questions appearing there, and we will convey it to the Zoom, to the speaker. Because of the limitation of this Zoom system, we can't allow more than 500 people. We have come up with some algorithm to allow only up to 500 people to attend those symposium talks. Thanks.
Yeah. So anyone else? Yeah. So someone asked that whether the registration is still on. Yes. You can still. You can. Yeah. So basically,
we have
to minimize these kinds of